Okay, year 11, I'm going to go through differentiation of exponential functions. Now, they just jump into it here and give you the derivative of the exponential function right here without any explanation, which worries me because I think you need to have an explanation. Also, they give you a couple of rules. This one, I don't want you to remember it. And I think there's another one, this one, I don't want you to remember it. So let's go through what are we going, or how this comes about. And I'm going to have to take some liberties because there's one limit where I'm just going to say we're going to use our calculator to get a value. So if we remember differentiation from first principles, so let's just take, remember we're talking about an exponential function, which is just y equals some number to the power of x. So let's take the number 2, which is y equals 2 to the x. Well, first of all, let's call it f of x. Because to differentiate this, remember the derivative f dash of x is the limit as h approaches 0 of f of x plus h minus f of x all over h. Okay, so let's take this 2 to the x. Well, first of all, we've got to find f of x plus h, which is pretty easy. We just put an h in there, we get 2 to the x plus h. So f dash x is the limit as h approaches 0 of 2 to the x plus h minus 2 to the x all over h. Now you need to know that 2 to the x plus h can be written as, so think about this, 2 to the x plus h equals 2 to the x times 2 to the h. So I'm going to factorise out here. I'm going to find the limit as h approaches 0 of 2 to the x. I'm going to take out the 2 to the x there, so I'm left with 2 to the h, and if I take it out there, I'm left with 1, and it's all over h. Now that 2 to the x doesn't have anything, any h in it, so we're going to take it, it's not going to be affected as for the limit as h approaches 0, so we'll take it outside. So 2 to the x, the limit as h approaches 0 of 2 to the h minus 1 over h. Now, here's where I'm going to take a liberty. I know that equals a value, or it approaches a value, and we're just going to use our calculator to work out what that value is. So we're going to create a fraction, and we're going to go 2 to the power of, and we're going to make a small number, so we're going to go 0.0001 minus 1 all over 0.0001. We press equals, and we get 0.69. Let's double check by adding a few more zeros. Let's add about 3 more zeros in there. So 1, 2, 3. We'll go upstairs. 1, 2, 3. 0.69. So, and you just have to take my trust on this. So it's going to be 2 to the x times 0.69 ... And that's how we differentiate an exponential function from first principles. Now, let's take 10 to the x. So f of x equals 10 to the x. Well, f of x plus h equals 10 to the x plus h. Now, I'm just going to take another liberty here. We know that the same thing is going to happen and that my derivative will be 10 to the x times the limit as h approaches 0 of 10 to the h minus 1 over h. So this time you have to change, that's going to be, this is going to become a number, it's going to approach a number, and what is that number? So we just have to go and change that 2 to a 10. Actually, it's quicker if we go this way. And we'll put a 10 there. 2.3. So when we do it this way, when we've got 10 to the x, it's times 2.3 dot dot dot. Well, if I look at this, 2 to the x 0.69, 10 to the x 2 point something, I wonder if there's a number, that when I put it to a power, or when I put it to the power of x and I differentiate it, I get 1. Wouldn't that be incredible? Wouldn't that be fantastic if there was a number for which that happened? And there is. So imagine e to the x times the limit as h approaches 0 of e to the h minus 1 on h. Well, let's go back to our calculator, and instead of 10, let's go and put e. And remember, e we can get by just going alpha down there. Oops. And look at that. This equals 1. And why is that so phenomenal? Well, if y equals e to the x, y dash equals e to the x. When you differentiate it, you get the same thing. And that is quite beautiful. The derivative of e to the x is e to the x. Now, don't remember those other two things. Just remember this. To derive any exponential function, it's the same thing multiplied by the derivative of the exponent. So, I'm just going to do a couple of easy ones here. So here's 1a, y equals 9e to the x. That's, the derivative is just the same thing, 9e to the x. b, y equals negative e to the x. Well, the derivative is just the same thing, negative e to the x. Oops, let's make that x a bit better. But what about when I get something in there? So for example, and I'm going to make one up. What happens if I get y equals e to the x squared? Well, I'm going to let u equal x squared. Therefore, du dx, the derivative of that is 2x. But it also means I can write y equals e to the u. And y du equals e to the u. And luckily, we've already discovered or remember or learnt that there is a chain rule that says that dy dx equals dy du times du dx. Now please remember, they're not fractions, they're not going to cancel out. They are in a sense infinite fractions, so yes. But That's the same thing, the e to the u, and that's the derivative multiplied by the derivative. So what do we get? dy dx equals e to the x squared, because remember u is x squared, multiplied by 2x. And we tend to write the 2x out the front. So 2x e to the x squared. Now, you don't have to show this every single time. You can just go straight from here to here, which is what I would expect you to do. So if I look at 2a, where we have y equals e to the 2x, well, it's the same thing, e to the 2x, multiplied by the derivative of the exponent. Well, the derivative of 2x is 2. And I'm going to put it out the front. Have a quick look at b. Y equals e to the negative x. Well, the derivative, y dx, is the same thing, e to the negative x, multiplied by the derivative of the exponent. Well, that's minus 1. Now you can write the minus 1, or you can just write minus e to the minus x. And that's all you have to do. Now, there are other situations in there where you're going to have product rules. So, for example, here you're going to have a product rule. You're going to have a quotient rule. There you're going to have a product rule. And here you're going to have a fat finger, well, function of a function rule. Our terminology is a fat finger rule. So here, this one is going to be a product rule. So I'm going to quickly do 2h. Now, 2h y equals x e to the 4x. I think that was a question. Let's have a look. Yep. So the derivative, and you need to remember and say it out loud if you can. It's the first x times the derivative of the second. So it's just the derivative of this e to the 4x. Well, the derivative of e to the 4x is the same thing, e to the 4x multiplied by the derivative of the exponent. Well, I'm going to put that 4 in there. So 4e to 4x. So that's the first times the derivative of the second, plus the second, e to the 4x, times the derivative of the first. And the derivative of x is 1. Now, I'm going to factorise out e to the 4x. And when I take that e to the 4x out the front, I'm left with 4x and a 1. Okay? So you still have to use your product rules and your quotient rules and your chain rules and your function of a function rule or fat finger rule. But now you've got this added beautiful, beautiful derivative of an exponential function. And try and remember to say the words, the same thing multiplied by the derivative of the exponent.